Hello, in this video tutorial, we're going to be looking at the application, the quadratic formula. Now, the quadratic formula is something that essentially allows you to solve any quadratic equation without you knowing how to factor it or not factor it or whatever. It allows you to solve any quadratic equation. And when you get higher into math, you also learn that the quadratic formula can yield sometimes two real solutions, two imaginary solutions involving the imaginary unit I, and sometimes no solutions and sometimes one solution. So it depends on the situation, of course, but the quadratic formula can yield any of those four possibilities. In this class, in physics, we will not deal with imaginary units, as quadratic formula is used for motion studies and essentially evaluating position as a function of time, right? And time is not an imaginary thing, all right? It's definitely a real thing and a positive thing for that matter. So do keep in mind that in a math class, while you may have positive and negative solutions using quadratic formula, in the real world of physics, you're only going to have positive solutions for certain variables, such as time, okay? So without any further ado, let's get into this brief lesson on quadratic formula. So remind yourself, a quadratic equation has the look ax squared plus b times x plus c equals 0. This is called the standard form. Okay, standard form for a quadratic. Okay, now what we're going to be doing here is we're going to essentially be identifying, okay, in each problem, an a, which is the coefficient or the number in front of x squared, a b, which is the coefficient or the number in front of x, and a c, which is the trailing number after x. Okay, you're going to be identifying a, b, and c to start any quadratic formula problem. Then what we're going to do is we're simply going to substitute a, b, and c into quadratic formula. So what is quadratic formula? Let's write it down. X is equal to negative b, right? You can see b right here, plus or minus the square root of b squared minus 4 times a times c. All of that is written over 2 times a. So if you've not done much work with quadratic formula, it can look a little intimidating at first, but essentially, first step, substitute the numbers a, b, and c. Second step, we're going to evaluate this part under the radical known as the discriminant. Okay, this part here is called the discriminant. You're going to evaluate that part first. Okay, and then you'll take the square root of it. Then lastly, you're going to add the, or you're going to take the negative b plus or minus the square root of that discriminant. And then finally, we'll divide it by 2 times whatever a is. So essentially, it's going to take us about 3 or 4 steps to evaluate the quadratic formula, okay? But it's very systematic, and it's the same 4 steps all the time. So we have a few questions here, so let's go ahead and break this down, all right? 49. Well, a is 1, because I don't see anything in front of x squared, so a is 1. B is 8, positive 8, and c is positive 1. So we start there. We're going to insert into this formula here. Okay, x is equal to negative. Okay, now b is positive 8, so we're going to put in 8 in place of b. Okay, plus or minus square root of, now we're going to take that same b, but we're going to square it this time. Minus 4, 4 is part of the equation. Okay, now 4 times a times c. So the minus 4 times a times c all over 2 times a. So actually what I'm going to do, let me just go ahead and copy this down And I'm going to be substituting into this for each problem. Okay, there we go. All right, so the b term is 8. Okay, then we're going to go 8 squared. All right, minus 4 times a, which is 1, times c, which is also 1, over 2a, which is 2 times 1. Okay, now start with this part here. That's going to be x is equal to negative 8 plus or minus, okay? Now, when we evaluate this, we get 8 squared is 64. 4 times 1 is 4. 64 minus 4 is 60, okay? So we're taking the square root of 60. Now, when you take the square root of 60, so this is plus or minus the square root of 60 over 2 times 1, which is 2. Now, at this point, we have a plus and a minus, so we can split it into 2 possible answers. Negative 8 plus, well, the square root of 60 is about 7.75. Divided by 2 equals, and then we'll split it into the other possibility, which is negative 8 minus. Remember, 1 is plus, 1 is minus. So minus 7.75 divided by 2. Okay, pause the video and go ahead and complete the calculation for the 2 solutions using quadratic formula. Okay, so the first solution we should have gotten for the top is negative 0.127. And for the second solution, negative 7.88. Okay, number 50. Again, if it's in this form here, if it's in standard form, then just begin by identifying A, B, and C. If it's not in standard form, you have to rewrite the quadratic to get it in standard form first. So it's in standard form, so A is 1, B is 7, and C is negative 2. Okay, let's substitute into quadratic formula. So negative b, so negative, insert the 7, plus or minus square root of, now we're going 7 squared, minus 4 times a, which is 1, times c, which is negative 2, over 2 times a, so it's 2 times 1. Okay, I think we have some room down here, so we'll go x is equal to negative 7 plus or minus, okay, now if we evaluate the discriminant here, we get 7 squared is 49, negative 4 times 1 times negative 2 is positive 8. So 49 plus 8 is 57. Take the square root of 57 and we get 7.55. Okay, so we're evaluating negative 7 plus or minus 7.55 over 2. Okay, you're going to have 2 possible answers. One is involving the plus, the other is involving the minus. So the first one, we're going to go negative 7 plus 7.55, then divide that by 2, and we get 0.275. For the bottom one, we're going negative 7 minus 7.75, and then we're going to divide that by 2. And for that one, we're getting negative 7.275. Please make sure you're practicing entering this in the calculator yourself. Okay, number 51. A is going to be negative 2. B is going to be negative 3, and C is going to be 1. Okay, so let's go ahead and enter this into quadratic formula. Negative b, so b would be negative 3. Now keep in mind, guys, you're going negative times a negative, so that's going to be a positive, right? So we put in the negative 3 for b. And then we're going to put in the negative 3 for b here too, b negative 3 squared, minus 4 times a, which is negative 2, times c, which is 1. All over 2 times a, which is 2 times negative 2. Let's go ahead and evaluate this a little bit. Okay, one possibility, if we evaluate the discriminant first, okay? So negative 3 squared is 9, because negative 3 times negative 3 is positive 9. And then you have negative 4 times negative 2 times 1 is positive 8. Okay, so 9 plus 8 is 17. Negative times a negative is a positive, so we have 3 plus or minus the square root of 17 over negative 4. Let's go ahead and get our two solutions here. 3, okay, when you take the square root of 17, you get about 4.12. So positive 3 plus square root of 17 divided by negative 4, okay, is about negative 1.78. Okay, and then on the bottom, if we go 3 minus square root of 17, divide that by negative 4, we get 0.28, positive 0.28. Okay, one question remaining. A is 2, B is 5, and C is negative 3. Let's go ahead and enter this in the quadratic formula. Okay, so we're going to go negative 5 plus or minus the square root of 5 squared minus 4 times A, which is 2, times C, which is negative 3. And your 2 times A, which is 2 times 2. Okay, now we're going x is equal to negative 5 plus or minus the square root of, when you evaluate the discriminant here, we have 5 squared is 25. Negative 4 times 2 times negative 3 is positive 24. So we're basically going 25 plus 24. Well, what's nice about this is 25 plus 24 is 49, square root of which is 7. So that's kind of nice, over 4. So this is basically negative 5 plus or minus 7 over 4. Here's our two answers. We're going negative 5 plus 7, which is 2 over 4. You get 0.5. And negative 5 minus 7 is negative 12 over 4. You get negative 3. Remember, even though mathematically we can get positive and negative answers, remember, in the real physical world, sometimes a particular variable does not have a negative concept. I hope you found this video tutorial to be helpful. Thank you. See you next time.